Yes, Year 12. I hope you're excited. We've got a new topic that we're starting today. It's called integration. This is integration 1, the first lesson on integration. Write a title and learning objective down on a piece of paper. Pause the video so you've got time to do that and press play when you're ready to continue. So the textbook will tell you that integration involves all kinds of different rules, all kinds of tricks, not tricks, all kinds of long things that you have to remember in order to integrate properly. But fortunately, I've got some good news for you. I'm here to tell you that if you know that to go from y to dy by dx involves differentiation, which hopefully you all do because that's why you're watching this video, because you did last week's work and you're clear about how to differentiate, then integration is what takes you from dy by dx back to y. In other words, integration is the reverse of differentiation. Integration is when we're given the gradient function, we're given the first derivative, we're given dy by dx, those are all names for the same thing, and we want to find the original function y. And we integrate to find it. So make sure you've written that down. That's the only thing you need to remember in terms of integration. That's it, which is great because the textbook, we can just basically ignore all the stuff the textbook's saying and just remember that. So, but make sure you've written that down because that is very important. All right, so let's look at what this looks like in practice. Here we've got example 1. It says find y for the following, and if we look at part A first, it says dy by dx equal to x to the power of 4. So I want you to pay particular attention to how I present this and how I show my working. I'm going to write dy by dx down here. And what I'm going to write above it is y equals. Now this over here, this is going to be my answer because I'm being asked to find y. Why do you think I've written y above dy by dx? It's because I want you to think of y as being the starting point. We differentiate to get dy by dx, and we integrate to go back to y. So I want you to think of y as being the starting point, and integration is how we get back to there. Now, because you're all masters of differentiation at this point, after the last couple of weeks of work, hopefully you know that the expression that we need for y that differentiates to this requires us to have an x to the power of 5. Because when we differentiate x to the power of 5, we get 5x to the power of 4. I'm going to give myself a bit more space here. We get 5x to the power of 4. And you'll notice when we do that, the power here is the same as the power here, which is exactly what we're aiming for. You always start by looking at the powers, or the power. So I look at the differential, having written it out beneath y. So I start off by writing the differential here. I write y equals here, step 1 and step 2. After that, I look at the power and I ask myself, what must the original function of y have as its power in order to differentiate to get this 4 here? Obviously, in this case, it's x to the power of 5 differentiates to x to the power of 4 with something in front. Once you've figured that out, all you need to do is you need to ask yourself, what do I need to times this constant by, this coefficient of x to the power of 4, so that it is the same as the one that I'm aiming for, which in this case is just 1. What do I times 5 by to make it into 1? I times it by 1/5. 1/5 times 5 is just 1. And so because the constant doesn't impact what happens when we differentiate, all I need to do is write this up here. And so that is now my answer. Y equals 1/5 x to the power of 5. Let's just double check that works. I want you just quickly to integrate this expression, differentiate this expression here and see if it equals what we were aiming for, which is this one here. Have you checked that it works? Good. That is pretty much all the integration is, guys. That's it. However, there's one little extra bit that we need to think about. So we've already said, I'm going to rub out this working. We've already said that 1/5 x to the power of 5, this thing here, this differentiates to x to the power of 4. Can you think of anything else that differentiates to x to the power of 4? Pause the video and have a think if you can't already notice, if you haven't already thought of one. All right, well, I'll write some down. What does that differentiate to? Yep, it differentiates to that because the constant over here differentiates to 0. Can you think of another one? What does that differentiate to? Hopefully you've spotted a pattern already. Yes, it differentiates to that. What does this differentiate to? Again, it differentiates to that. Now the point is, if our starting point, our y, could be any of this, this, we don't know, then when we integrate a derivative like this, we have to show that there's more than one possible original function. And in fact, there's an infinite number of original functions. Can you think how we might represent that when we integrate? Well, we represent it like this. We say that if the derivative is x to the power of 4, then the original function y equals 1/5 x to the power of 5 plus c. And we write this plus c to show that any of these situations where we've got a constant in the original function, any of these situations would still differentiate to this. So our final answer for part A, just to be really clear, is that. So let's go through B again. Sorry, B for the first time. That's A, that's B. Watch how I set this out. I'm trying to find y equals, I'm told dy by dx equals x to the negative 5, which is the same as 1x to the negative 5. That 1 is going to be important because it's going to come up when we try and figure it out later on. I'm now going to write y equals, and I'm looking at this power, and I'm saying, what must the power of x be over here in order for it to differentiate to negative 5? Well, more than negative 5, negative 4. And when I differentiate that, I get x to the negative 5, and obviously the power comes down here, so it's negative 4x to the negative 5. However, I've not finished because I need to somehow get the constant here so that it is the same as here. So what do I have to times negative 4 by to make it into 1? Well, I have to times it by negative 1/4. Negative 1/4 times negative 4 gives positive 1. So I'm going to write that in here. So it was negative 4, but I'm going to times it by negative 1/4, which means I'm going to times this thing by negative 1/4. And so my answer is going to be y equals negative 1/4 x to the negative 4 plus c. And this is my final answer. How do you think we can check that this is correct, guys? Well, hopefully you're thinking straight away, let's just differentiate this to see if it does equal this. So you can pause the video and do that now. And hopefully you're clear that that works. So pause the video, make any notes that you need to. It's a little bit of a long process to start off with, but trust me guys, if we master this process and you set it out how I'm telling you to set it out, it will all be very simple when we start doing more complicated integration later on, both this year and next year. All right, let's look at the second example. So, part A, we're told f dash x equals this, so we're trying to find f of x. Look how I'm setting it out, always the same. You can pause the video and try and do this on your own now. In fact, have a go at doing that now. Press play when you're ready for me to show you how to do it. So what we're going to do, we're going to look at this power and we're going to say, what does f of x need to be so that we get a derivative that looks like x to the power of a half? Well, it needs to be one more than that. It needs to be x to the power of 3 over 2. When I differentiate that, what do I get? I get 3 over 2, x to the power of 1 over 2, which is what I was aiming for. However, at the moment, my constant is 3 over 2. I'm looking to get 3. So what do I times 3 over 2 by to make it into 3? I just times it by 2. So I write 2 there, which means I write 2 here, which means my answer is 2x to the 3 over 2 plus c. The working out that I'm going to insist that you have, that you must have, is everything that you can see on the screen right here. So please make sure that you've got that, and if you didn't set it out exactly how I've set it out, then purple pen it please. And if you need to pause the video so you've got time to make some notes, then do that and press play when you're ready to keep going. All right, I'm going to let you have a go at part B. In fact, I'll leave that on the board. What's going on? I'll let you have a go at part B. Sorry, you're not getting on the board. Hopefully your notes were good enough. Have a go at part B on your own and pause the video so that you've got time to do that and press play when you're ready for me to show you. So, we're trying to find f of x, we write at the top. We're given that f dash x is 3. By the way, is 3x to the power of 0, just to remind you. Because x to the power of 0 is just 1. So, we ask ourselves, what does f of x need to be in terms of powers of x in order to differentiate to that? The power needs to be x to the power of 1. And if I differentiate that, I get 1 x to the power of 0, in other words, just 1. What do I need to times 1 by to make it into 3? I need to times it by 3, which means I'm going to times this by 3, which means f of x must be 3x plus c. And that is your answer. Pause the video again and make any notes that you need to, and then we'll move on to another example. Okay, so if you think you can have a go at this on your own, then go for it, please. If not, still have a go for it, and press play when you're ready to check if you were correct. So y equals, that's what we're trying to find, and we're told that dy by dx is equal to 6x plus 2x to the negative 3 minus 3x to the power of a half. So let's look at what y, the original expression for y, would have to be in order to make these powers, 1, negative 3, and a half. Well, to differentiate to x to the 1, it would have to be x to the 2. And when we do that, we would get 2x. To differentiate x to the negative 3, or to differentiate to get x to the negative 3, we would have to have x to the negative 2, 1 up from negative 3. And when we differentiate that, we get negative 2x to the negative 3. And finally, what would x need to be to differentiate to get x to the power of a half? It would need to be x to the 3 over 2. When we differentiate that, it would be 3 over 2 x to the half. Now at this point we can see we're correct because in our derivative over here, the 1 is the same, the negative 3 is the same, and the half is the same. But the constants are not correct. So I now have to ask myself, what do I times 2 by to make 6? Times it by 3. Which means this over here needs to be 3x squared. What do I times negative 2 by in order to make it? So let's just rub this out. What do I times negative 2 by in order to make it positive 2? I times it by negative 1. So that means this one has to be negative 1, or negative x to the power negative half. And finally, what do I have to times 3 over 2 by to make it into negative 3? I have to times it by negative 2. Let's just write it out just to make sure. 3 over 2 times negative 2 over 1. They cancel and I get negative 3, which is what I was aiming for over here. So I have to times it by negative 2. Which means I'll write it up here. So therefore, my solution, my actual integrated answer is this. But remember, we have to say plus c to show that it could be any constant there. We don't know what it is. So pause the video and make any notes that you need to. And if you need to rewatch that example, then obviously do that. Rewind it and rewatch it until you're clear about how to do it. And I'm just going to show you 1 or 2 questions from the first part of the exercise 13a, because I think it would be helpful for you to see how I do it. So I'm going to pick a couple of spicier questions. I'm going to go for 1f. So it says find the expression for y when dy by dx is the following. And we're told that dy by dx equals 4x to the half. And we're trying to find what y is. Pause the video and have a go at this on your own and press play when you're ready for me to go through it. So as always, we're going to look at the power first. And I'm saying, what does x need to be to the power of to differentiate to x to the half? Well, it needs to be to 3 over 2. Which means dy by dx, that would do, this would differentiate to get 3 over 2 x to the half. That's good, that's what I was aiming for over here. But I somehow need to make this 3 over 2 into a 4. What do I times 3 over 2 by to make it into 4? Well, you can just think of this as an equation. 3 over 2a equals 4, times both sides by 2, divide both sides by 3. So that's what I'm going to times my constant by, which means my constant up here is 8 over 3, which means my answer must be 8 over 3x to the 3 over 2 plus c. Don't forget about the plus c. And so this is the answer to question 1f. Make any purple pen notes you need to. And I'll do one more question because it is, actually, you know what? I'm going to leave the rest up to you. Now, this is something you'll need to practice properly, guys. Don't do any of these shortcuts where you think you're not going to bother with the easier questions. You need to learn how to set out your work so that it looks like this. And over time, you'll get to a stage where you can do it all pretty quickly in your head. You won't need to write out this stuff. But for the time being, for today's lesson, I want you to set it out exactly how I'm setting it out. And you'll notice that every single question that I've done, I've set out in the same way. So have a go now at completing all of exercise 13A. And obviously you can email me or Miss Cooper if you need any help.